We have got very less time left, and today is only one presentation. Afterwards, till third term exam, no presentation at all. Okay, give a round of big round of applause. What is it doing? Okay. Now you local of Kathmandu, don't talk it. Yeah, local. They got double close the door. You go from that side, okay, Bimali? Khatri, Bimali go from that side. So to present the slides chapter, let me welcome on the stage our hero, Youth Pariyar. So Youth Pariyar, Youth Pousha, Youth Nepali, what do you have to say?
Namaskar and very warm welcome to on my sir and my friends as well as me here to present the presentation of fourth chapter. When a stone drop into a quiet pool of water, a number of whirlpools are formed in the water surface from the point where the stone is dropped. The whirlpools are called waves. Water waves on the surface of water are the example of wave motions and is the figure of wave in water. Uh, Waves and their types. Mechanical wave. This is a wave with vibration in matter that transfers energy through a material, and these waves can be longitudinal or transmovable in nature also. And second one is electromagnetic wave. It is a type of radiation that travel through space and these are made of oscillating electric and magnetic fields. The main properties of electromagnetic waves are they are transfer waves. They are unaffected by electric and magnetic fields. Waves can be classified into transverse and longitudinal wave. Transverse wave, a motion in which all points on a wave oscillate along paths at right angle to the direction of the waves. And advanced is called transfer wave. This wave can be passed through solid and liquid, and it is the figure of transfer wave. Longitudinal wave, a wave vibrating in the direction of propagation. A sound wave is also an example of longitudinal wave. It consists compressions and refractions. This is the figure longitudinal wave, and this is the difference between transfer wave and longitudinal wave. Longitudinal, the particles of medium vibrate in the same direction, and the transfer is the particles move at right angles to the direction of wave propagation. They are possible in all kinds of media. They are possible only in solids. They consist of regions of compression and rarefaction. They are consist of pressed and troughs. They can be polarized and they can be polarized. Sound waves in air and is an example of longitudinal wave. And vibration, string is an example of transverse wave. Some terms related to the waves. Twist and throw. Both transverse and longitudinal waves are represented graphically by sine curve as shown in the diagram. Transverse waves travel in the form of trough and crest, and it is this crest and this part is called trough. Compressions and rarefactions. A longitudinal wave travels in the form of compressions and rarefactions. In a rarefaction, density is less than normal density, and this is the rarefaction, and this is the compression. Amplitude, the maximum displacement of particle from its mean position in a wave is called amplitude of the wave. And frequency, the number of complete wave set up in a medium in 1 second is called frequency. The SI unit of frequency is hertz, that short form is exact. Heat, sound, and light are few forms of energy. Some of them, like light, can be seen, but heat and sound cannot be seen. All of them transmit from place to place in the form of electromagnetic waves. Electromagnetic spectrum. Electromagnetic waves are the waves which carry energy by the vibration, by a variation, periodic change of electric and magnetic fields. These waves can be propagated through vacuum at high speed in 3 into 10 power 8 meter per second. Visible lights, radio waves, X-ray and X-rays and Y-rays are the some example of electromagnetic waves, and it is a figure of electromagnetic spectrum. Some electromagnetic waves and their applications. Radio waves. Beyond the infrared region, there is a wide range of wavelength to form about 10 to the power minus 1 meter to 10 to the power 3 m, known as radio waves. Radio waves are produced by electrical oscillations. The main use of radio waves are widely used in means of communication like radio, television, etc. These are used in telescope for the study of the space also. Infrared radiation. When we sit near a fire, we feel warmth because of its invisible infrared instead of visible light. When a body absorbs red, it gains energy and becomes water. And their uses are they are used as a source of heat, and they are used in remote control. And visible light, the wavelength of visible light is in the range of 4 into 10 power minus 9 meter to 7.5 into 10 power minus 7 meter. The wavelength of red light is about 8 into 10 power minus meter, and that violet is 4 into 10 power minus 7. And ultraviolet rays. Ultraviolet rays is just beyond the violet, in of the violet and in of the visible spectrum, whose wavelength is in the range of 4 into 10 to the power minus 9 meter to 10 to the power minus 8 meter. It can be treated by photographic films. The main use of UV rays are given below. They are used in bulbar alarms. They are used for detecting real period. X-ray. Wavelength of X-ray is 10 to the power minus 7 meter to 10 to the power minus 9 meter. X-rays are produced when very fast moving electrons are stopped by a heavy metal, and it is the use of X-rays. It is used to scan luggages during security check, and it is used to identify the presence of black holes in space. Gamma rays. Wavelength of Y-ray is less than 10 to the power minus 11 meter. They are produced by radioactive decay and nuclear reaction. Uranium is the main source of this energy. It is very harmful to our body, and it kills our cells, and it can also cause cancer too. And there are some uses of gamma rays. They are used in the study of space, and they are used in the fertilization of surgical accessories. X-rays and CT scan. X-ray. X-ray are form of high energy electromagnetic radiation with short wavelengths. They can be penetrate materials, making them useful in medical imaging. Examples: X-ray scans to view bones and organs, and industrial applications. Example: inspecting materials. X-rays are observed differently by tissue and bones, producing image based on density. While valuable for diagnosis, excessive exposure can be harmful due to their weak nature, and it's the X-ray machines. CT scan. CT, computed tomography, is a medical technique that uses X-ray and computer processing to create detailed cross-sectional images of the body. It provides a 3D view of internal organs, bones, and tissue, helping diagnose diseases, injuries, and abnormalities. CT scans are faster and more detailed than standard X-rays, but involve higher radiation exposure. And is a figure of CT sonography reflection of
You're yawning and chest. How many times?
the process by which sound is sent back by surface into the previous medium is called reflection of sound. Echo and reverberation are products of reflection of sound. Echo is the reflection of sound wave that occurs when they bounce off a surface such as wall, mountain or buildings and return to the listener. It is most noticeable when the reflected sound is delayed long enough to be heard distinctly from the original sound. Reverberation. Reverberation is also known as the persistence of sound in an enclosed space due to multiple reflections from surfaces like walls, ceilings, and floors. Unlike an echo where the reflected sound is distinctly heard after a delay, reverberation occurs when reflections overlap and blend with the original sound, creating a prolongated effect. Uses of reflection of sound. The reflection of sound has various particle applications in daily life and technology. It is used in echo sounding to measure the depth of water bodies and locate underwater objects through sonar sound navigation. And when in medical imaging, techniques like ultrasound rely on sound reflection to create images of internal organs. Reflection also plays a vital role architectural design, where it is considered to enhance sound clarity in autos and theaters. Hearing aids use reflected sound waves to amplify sound for individuals with hearing impairments. Additionally, reflection helps in the effective transmission of sound over long distances, such as in loudspeakers and public announcement systems. These applications highlight the significance of sound reflection in science technology. Ultrasound and sonography. Ultrasound is a non-invasive diagnostic imaging technique that uses high frequency sound waves to create images of the internal structure of the body. It operates on the principle of sound wave reflection, where a transducer emits sound waves into the body, and the echoes produced by tissues are captured and converted into images by a computer. Ultrasound is widely used in medical diagnosis, such as monitoring fetal development in obstetrics, examining abdominal organs like the liver and kidneys, and evaluating heart function through echocardiography. It also plays a critical role in guiding procedures like biopsies and minimally invasive surgeries. Additionally, ultrasound therapy is used in physiotherapy for relief. The method offers several advantages, including being painless, non-invasive, and safe, as it does not involve ionizing radiation, making it suitable for pregnant women. Its probability and cost effectiveness further enhance its clinical value. And ultrasonography. Ultrasonography is a non-invasive imaging technique that uses high-frequency sound waves to create real-time of internal body structures. It is commonly used in obstetrics, abdominal imaging, cardiology, and musculoskeletal assessments. The procedure is safe, cost-effective, and does not involve radiation, making it deep for monitoring fetal development and guiding medical procedures. And here is the example diagram of it. And thank you for the attention.
Thank you very much. And he didn't stop, so they is okay. Or not? Okay? Alright. So, next time, Bimali will do much better, I know. Okay, Bimali? We have to practice. So, what also, if you cannot speak, then what to do? Aye. Now count how many days are left for your examination. Sorry? Means very few days are there, right? Very few days. So who presented this information communication technology? Anmol's presentation was there, right? Now this wave, maybe a bit earlier one. So many things we have discussed, so everything you have to go through it. So he presented from this chapter. What a lovely time is here, see? Mainly, we can categorize wave into two types, either electromagnetic wave or mechanical wave, right? Electromagnetic or mechanical, or we can categorize them into transverse wave and longitudinal wave. Those things you have to keep in mind. Mechanical wave, they do not need medium. Transverse wave, electromagnetic wave, they need medium. What are the examples of electromagnetic waves? Which waves do not need medium? Light, X-rays, sound needs medium. Adhikari, we can confirm, hey boy. And these terms you have to remember. And he brought these things, many things he brought. Differences between transverse wave, longitudinal wave, crest, throw, wavelength, properties of this electromagnetic waves, different electromagnetic waves, full form of sonar. It was discussed. So today I will give you work from this chapter, and from today now your work is slightly modified also. From today I will give you reading work as well. Today I will give you 3 chapters reading. You have to read that chapter, write down the major points and set in mind and come here and express. Now I am going to ask you also. Understood or not? Right? So 3 chapters. So which 3 chapters I am going to provide you? Same, wave. Chapter wave, electricity and magnetism, and next one is ICT. Another universe. Chapter 10, 11, 12. Please write down. What is the homework? Chapter 10, chapter 11, chapter 12. Reading and writing and memorizing. That is your homework. 10, 11, 12. 3 chapters. Reading, not only reading, writing and memorizing. Whenever you come here front, you must be able to say correctly. Understood or not?
Yes, sir.
That is all. Okay, start now.